Good day, everyone, and welcome to the Atrium Ask the Expert, extending Atrium Discovery using the ADDM pattern language TPL webinar. Today's conference is being recorded. At this time, I'd like to turn the call over to Mr. Jim Davis. Please go ahead, sir.
Thanks, Amy. I'd like to welcome everyone to today's session in the Atrium Ask the Expert webinar series. We're glad to have a global audience today and especially appreciate the efforts of those joining outside of their business hours. Today's topic is extending ADDM or Atrium Discovery using the ADDM pattern language, or TPL. The webinar is presented today by Nikola Vukovljak, one of BMC Atrium's product developers. He's joined by a distinguished panel of experts from BMC R&D and support who will be answering questions you may have on this topic. At the end of the presentation, we'll be taking live questions over the phone. But during the presentation, if you have a question, please type it into the Q&A panel within the WebEx framework. At this time, I'll turn over the webinar to Nick. Nick?
Hello, Jim, and thank you. Welcome, everyone. Welcome to the webinar on the ADDM pattern language, or as we call it, TPL. Now, our agenda today is related to 4 different topics. Firstly, we'll talk about what is Atrium Discovery pattern language, or TPL. Then, using TPL for software discovery, things to look out for and best practices when coding in TPL, and finally, where to get more information and how to contribute to the Atrium Discovery community. So, let's first cover what is TPL. Well, it is a special purpose programming language that's specific to BMC Atrium Discovery. It is used to describe entities that can be modeled in Atrium Discovery, and its aim is to make it easy to model most of the common structures in the ADDM data model. It drives the discovery engine to obtain the necessary data to build the models in ADDM, and it was designed to be simple to learn as it abstracts the user from the rules engine that drives Atrium Discovery. So it is difficult to talk about TPL without a quick reminder about Atrium Discovery and its data model. The ADDM data model is designed to allow modeling of complex IT environments, and for that reason, ADDM uses a graph model that represents entities in the environment and the relationships between them. All data stored in ADDM is stored as nodes, and all of these have a kind and are described using key value pair attributes. Now, relationships in the model represent connections between the nodes. And the model distinguishes between different types or categories of information stored, with the categories being the directly discovered data, or DDD, inferred data, and pattern management data. Now, the 2 categories in the data model that are of greatest importance are directly discovered data, or DDD, and inferred data. The directly discovered data is obtained directly from a target host by a particular discovery technique. Some of this data is likely to change from scan to scan and includes things like running processes on a host, installed packages on a host, network interfaces, connections, etc. On the other hand, inferred data is the information that ADDM infers from other types, typically DDD data, using rules in the reasoning engine. This data is less likely to change from scan to scan, although it will change over time, and includes things like classification of hosts, software products running on the host, classification on network devices, etc. So to illustrate this, here's a diagram showing part of the DDD model. The nodes in the DDD model store the information about the target being discovered, as well as the discovery process itself. So the nodes are things like the device info, the host info, discovered process, the process list, or discovered access. On the other hand, the nodes in the inferred model are generated by ADDM based on interpreting the evidence that's in the DDD nodes. And often, they combine information from multiple DDD node types in order to create the inferred data model. So the host node, for instance, is formed from a number of different information from a number of different DDD nodes. So what are the uses of TPL and ADDM and its data model? Well, the principal use for TPL is to create or enrich inferred data nodes. And you can create inferred data nodes such as software instances, business application instances, etc., using information from the DDD. You can also enrich the data by adding attributes to existing nodes. Finally, you can also create relationships between nodes to enrich your data model. So the types of relationships you can create are communication relationships, dependency, etc. Now, another use for TPL is to transform the data from Atrium Discovery model to the Atrium CMDB model, or the CDM. Now, one thing that TPL must not be used for is to alter the directly discovered data, or DDD. The DDD must be managed by ADDM, and interfering can have serious consequences for the ADDM data model and therefore the data store. Therefore, really, all user-driven data modeling needs to take place in the inferred data part of the model. So now that I've given you an idea of the role of TPL, let's consider its use in software discovery, i.e. the key way we can extend ADDM. Now, the TPL code to discover software is written as Atrium Discovery Patterns. These are stored as pattern module files. And these pattern module files can be uploaded to ADDM, where they are compiled into ADDM rules. And these are the rules that are actually executed by the ECA engine. Now, Atrium Discovery ships with pattern templates, which are boilerplate code that enables you to get started quickly with coding in TPL. They also demonstrate best practice approach to software discovery. And they can be easily located in every single ADDM appliance in the pattern template section of the pattern management UI. Now, because they are patterns, they are not complete code, and the sections that need to be edited and updated by you are surrounded by the $$ characters. Now, the first important point to remember about patterns is that they are event-driven, and so is the ADDM reasoning engine, hence why this is the case. Events are generated during discovery or data model updates, and the condition or the event that will start pattern execution is defined in the trigger section of the pattern, and you'll see that in a moment. So let's consider a software discovery scenario. We have a task to discover a particular software product. Let's say it's Sybase Replication Server. Our initial research has identified a representative process. This will be rep server on Unix or rep SRVR exe on Windows. Now, we have also determined that each process corresponds to a separate instance on a host, and the instances can be told apart by looking at the command line of the process, where the -s command line argument sets the instance name. So here's an example on the slide of a process listing where we have 2 replication server instances with the instance names highlighted. Now, our first goal would be to identify the software under host. We can initially create just a simple pattern that will do exactly that. A good candidate template would be to use the SI instances template that we can download from our ADDM appliance for this purpose. So on this slide here, I'm showing you the body of that template. Now, starting from the top of the pattern, we'll update the code between the $$ boundaries to match our research. So first, we'll set a unique module name. Each module has its own name, and it must be unique. Then we can write a little pattern description. If you want to use multiple lines or multi-line strings, you can use triple quotes to put those in. We'll then optionally set some metadata that describes the pattern, and also set at least 1 tag. Now, the metadata and the tags are very much of use if you're then doing later a search for your pattern amongst many others. You can type in some of this information into a quick search in ADDM, and you're likely to find your pattern quickly that way. Finally, on the screen, we're also setting the software type as a constant to demonstrate the use of the constant block. We don't necessarily have to do this. We can also put this inside the body of the pattern. Now, moving on to the body of the pattern. Again, we update it. We'll first set the trigger condition. Now, because this product is running on both Unix and Windows hosts, we'll set a trigger condition that will cover both the Unix and Windows platforms. Now, you should also note the use of the Unix CMD and Windows CMD string qualifiers, which will simplify our regular expression writing for our trigger condition, as it sets the appropriate regular expression boundaries. We then also use a regular expression to extract the instance name. Now, the regular expression syntax that we use inside the regex extract function is, the TPL uses the same syntax as Python. So there's plenty of references that can teach you on how to use the regular expressions in TPL. If the code has managed to obtain the instance name, we'll use this as part of our SI key to create a unique instance for each running process. In certain cases, we may not be able to get the instance information. In that case, it's a good idea to write a section that will still create a software instance, but a much simpler one, what we would call a fingerprint, or sorry, a footprint. In this case, we will let ADDM actually create an implicit key, which will group all those processes where we couldn't get the instance name into a single entity. Now, after our initial effort, we've scanned the host, and here's some results. This was the host where I've shown you the process listing with a couple of instances of replication server. Well, our pattern has actually found those. And if we click through to look at the detailed view, we can see that we have also pulled out the instance information, and I've highlighted that on this slide. So the next step when we're creating patterns to discover software is typically to add code to discover the versions in our environment. ADDM allows us to use a number of methods, and it's actually good practice to implement more than one method in order to increase our chances of getting the version information. So some of the methods to discover software version would be active versioning, where we would use the discovery.run command function to run a command or chain of commands and then parse the results. We can also use file versioning in some cases, where we'll use discovery.fileget function to download the file and then parse the contents. Another approach is for products that are installed using a standard operating system installer is to use package versioning where we use the model find packages function to search for a package node and obtain the data. And on Windows, we can also use versioning through registry query, where we call the discovery registry key function to access the relevant registry key and then parse the results. There is an option of using WMI queries as well, where through the use of discovery WMI query, we can obtain the version details of an executable. Finally, on all platforms, we can potentially also parse the command line of either the trigger process or another process on the target host and get the version information that way. Here we would use a regular expression, of course, to do that. Now, the TPL functions I've highlighted here are not just used for versioning. They can be, of course, used to gather other data as well, and often are within patterns. So I'm showing them here in context of obtaining version information, but don't think of them as being just for that use. So let's move on to discovering the version of our software. The product SME advises us that the product can be versioned a number of ways. On the Unix platform, the primary approach will be to execute the binary with the -v option. And there's also an approach where we can, if we look at the log file that's specified by the -c argument to the trigger process, the first few lines contain the version information. So here's an example of a process listing where you would also see the path to the log file in question. Now, on the Windows platform, the primary approach would be to access a registry key. And we have also seen through our research that the trigger process path often contains the version information we could parse. So this gives us also another option. So let's first add active versioning on the UNIX platform. To implement this active versioning approach, we can again look at the ADDM templates for guidance. And the template we should look at is SI version command. Parts of the template that are of interest I've actually highlighted on this slide. So let's update our pattern using the codes from the template, adapting things as needed. First, to ensure that the active versioning code will execute only on the UNIX platforms, because that's the only place where it makes sense for it to do so, we'll place it inside an if block that will only be executed if the target host is of UNIX OS class. The command that we execute should also only execute if the path, i.e. the trigger process, has an absolute path. And this is quite important because, especially on Unix platforms, sometimes your local variables for your login account could actually allow you to access the same binary that's in a completely different directory. So to be on the safe side, we really want to only execute a command if we know the full path to it. Now, once we have executed a command and we've got some output, we want to parse it. We'll use a regular expression for that. Now, the output that would be created is, as you can see on the right side of the slide. And the regular expression is pointed to by the arrow on the left-hand side. If we have obtained the version information, we'll also want to update the name attribute of the software instance with that information. And of course, we can add the version attributes to the SI, and we should add the version attributes to the SI now that we're obtaining the version information. Now, for version discovery on the Windows side, we'll look at the SI version registry template for guidance and add the relevant code to our pattern. So here's the relevant part of the pattern, of the template pattern that we want to use. Now, since the code to perform the registry versioning is to be executed against Windows targets only, it is also put inside its own block of code inside the else statement. We then set the registry key, and note here the use of the raw string qualifier to prevent the backslashes being treated as special characters. Finally, when we're obtaining the version information and setting it inside a software instance node, by convention we'll set it as string. So it makes a lot of sense to use string interpolation on the result of our registry query to make sure that the value we have received from the registry has been converted to string up front. This is because sometimes the registry key function can actually return things as integers or floats because that's the way they've been set in the registry itself. Now, since it is good practice to have more than one versioning approach, we should also add path regular expression versioning as a fallback method. We will parse the information from the trigger process command line using a regular expression in the registry extract function. Now, we should, of course, only execute this code if previous versioning methods did not work. If we have already obtained the version information, there's no point executing this code. You should also note here, when we're doing our regular expression parsing, we're also doing text substitution in order to construct a version number. If you recall from the process command line, the version was present in the path, but it was shown as major underscore minor, whereas really we want to present it as major.minor, which would be the normal way of presenting a version information. So we're using text substitution during regular expression parsing to do this. So here's some results then of after we have implemented our versioning in the pattern. Here we have a host, a UNIX host that has Sybase Replication Server 12.6 running. And if we click on Show Provenance button in ADDM, we will see that it has obtained this version information from discovered command result. So what does it mean? Well, if we click through, we'll see the actual detailed view. It means that Discovery has run a command. It shows the command that it has executed, and the result, the output that came back, that we parsed. Now, on the other hand, here we have a Windows host that's running Sybase Replication Server 15.1. The provenance information here is telling us that this version came from registry. So clicking through, we can see the registry key that was used and the value that was obtained from it. And finally, here's another UNIX host, also running 15.1 of Sybase Replication Server. But in this case, the provenance is telling us that the version came from discovered process. So this is pointing us towards the path and the regular expression, parsing of the path using a regular expression. If we look at the details, we will see that, in fact, yes, it is the command line and arguments that have been presented here, and I've highlighted the area of the path that we have actually parsed using a regular expression. Now, for the product we're discovering, we could also consider adding an additional versioning method for the UNIX platform. Remember that the SME has told us there are a couple of different methods of obtaining the version information. So there is a log file that also has this information right at the top of the log file. Here's an example of the beginning of this log file. Now, as the version is at the beginning of the file, we can consider two approaches here of obtaining this version information. One is to download the file and then parse it in our pattern. Now, for this, we would use the discovery.fileget command and then parse the information using a regular expression. Another approach would be to actually run a command on the host in order to obtain just the data we require or a much smaller amount of data. And that's very easy to do on a UNIX host. We could run a head command, which will return the first 20 lines of the file, and then parse the output of that. Now, for this particular product, this second approach is much better because the log file can be very large, and we don't really want to store the whole log file in the ADDM data store, which you would do if you did the discovery file get command. Now, let's say we've written our pattern, it activates, but the results are not as expected. So what do we do? Where do we look? Well, we can add some log statements in our pattern, but perhaps a log warn statement, which will allow us to easily follow the flow of the code. We then upload this pattern and create a manual group with hosts that we are scanning. We locate the pattern in the ADDM Pattern Management UI and perform a manual pattern execution run. At the end of this execution run, we'll have a log file that we can examine and hopefully find our issues. We may in some cases also need to perform full discovery run and examine the logs. In this case, you will often want to set the discovery and reasoning logging levels to debug temporarily, as well as potentially Windows proxy log to debug in case you're scanning against the Windows host. And then look at those logs and the detailed information they provide in order to find the problem with your pattern. Of course, once you have done this, once you have found the issue, solved it, remember to reset your logging levels to their usual settings. That way, you will not be writing too much data to the log files. And also, either remove the log warn statements from the pattern or set them to log.debug instead, so that during the normal execution runs, they will not be stored in the log files. Okay, now I'll cover some of the other features of TPL that we're not demonstrating in our example here. Many patterns need to search for data that's already stored in the ADDM data store, and therefore TPL has full access to the Atrium Discovery search service. Results that come back from calling the search service are either returned as node sets or lists. Now, one other feature that TPL has within the search expressions is that you can use an in clause to refine your initial search expression and not search across the whole data store. So here's a code example where we have started our search from a software instance node, and then we could immediately traverse to a detail node and perform some actions there. Now, one other feature of search service, key expressions are fully supported in TPL. They are supported both in search function calls and in direct usage. And the result returned is always a list. So again, here's an example of the syntax to use the key expression. And also an example of how you would check that the list actually has been populated with at least one result. So you can then access the member of that list to obtain the value. Now, discovering software also involves creating relationships between related components of the software. Your patterns will therefore often need to create the relationships between the nodes in TPL. Now, when researching software, you'll often find that the information about relationships can be found in config files, in registry keys, in the process command line even. And this information you can, in that case, really obtain in the same way through the use of discovery and model functions as you would obtain the version information. Now, once we know what to relate with our node, we can locate the other nodes using the search service. Once you have located them in the data store, you can create relationships using the model.rel functions. So here's a little code example where we want to relate our SI to a database server SI. We have obtained within the pattern the information about the database host, its name, and also the name of the database instance. We then pass this information to a helper function that ships with every TKU called related RDBMS SI search, together with SI type we are searching for, the database server type we are searching for. And this function will perform a search in the data store and hopefully return to us the software instance that we can relate to our SI node. If the function has returned this to us, we can then call model.rel communication, if we're creating a communication relationship, to relate our SI node with the database server SI node. Now let's now revisit some setting of the SI key when creating an SI node. SI key is the global unique identifier of the SI node. Each SI node that corresponds to a distinct distance of running software will have a different key. TPL allows us to specify the SI key and how it is set. So the choice of the SI key will directly influence how software is modeled in Atrium Discovery. Now, when we're discovering software, we often see one of the 4 common deployment models. We might have a readily identifiable instance of running software. That's, for example, our Sci-based replication server example. Here, we should use the identifier as part of our SI key. We could also have a situation where we have multiple processes that can be grouped in some way. For example, by installation path or by version or something else. In this case, it would make sense to group them using an explicit key group corresponding to the grouping criteria. Now, on other hosts, we might have a situation where we have one or more processes that represent a single entity on that host, and you can only have one of those. In this case, this is often seen with Windows software. Now, in this case, we should use a simple key that's just based on the type of the software and the host key. And finally, you can have a situation where there are multiple instances of processes, but they cannot be uniquely identified in any way. In this case, it would make sense to let ADDM create an implicit grouped key and not try to create an explicit SI key. You can really see examples of all of this in the various TKU patterns and also in the templates themselves. Now I'll move on to the things that you need to look out for, or the gotchas, and best practices to follow when you're coding in TPL. While you can add attributes dynamically to nodes in TPL, you cannot define new node kinds or relationships before they have been defined in a taxonomy extension which has been uploaded and validated in ADDM. This is a safety feature to preserve the data model. Be also aware that in general, TPL only supports integer arithmetic. Searches will return either a node set or list, never a single value. So accessing the result in a single value will always lead to runtime error. The XPath functions that are also present in TPL always return a list as well. So here's an example of the use of the XPath function and how you would check that you have obtained at least one result back in order to access it. Now, TPL uses Python regular expressions, and they are a powerful feature for parsing data. But be careful with their use and watch out for the regex of doom, i.e. an inefficient regex that can make ADDM unresponsive while it's trying to execute it. The compiler won't catch these for you, so it's a very good idea to use a regular expression checker, such as, for example, Kodos, which I use, but there are others out there like regex coach, etc. Now, before you access attributes of a node, make sure that the node actually exists. It's not none. If you cannot be sure, your code should check for this. Likewise, many TPL functions cannot handle being passed a none object. So again, your code should check for this before passing the value to them. And this is what a lot of the code in the pattern example actually does. Now, regex extract function can actually handle being passed a none object. In this case, it will just return an empty string. But of course, you might want to check for this because you're likely to be using this further in your pattern. Now, if you're using static lookup tables, for example, to convert version numbers from one form to another, you should really always add a default value. This will prevent a runtime error if the value in your variable matches none of the values in the table. Now, TPL has time functions, which directly map to Python functions that perform the same operations. Now, the only difference being, however, that in TPL there is no exception handling. So it's good to be, you should really make sure that you have a good idea of the data you're trying to manipulate here with the time functions. And finally, consider carefully the model for your software and set the SI key accordingly. Okay, so hopefully I've got you interested in TPL. And so where can you get more information and how can you contribute? Well, we have online documentation that describes TPL in detail, and that's on our discovery.bmc.com site. You, of course, have the pattern templates, which ship with every single instance of ADDM appliance. They will show you the best practice approach to writing code in TPL. There are also TKU patterns, the knowledge update patterns. These are released every month, and all the patterns are documented, again, on the discovery.bmc.com site. Now, if you want to exchange ideas and have discussion with other people, we have two forums, one on the BMC community website, and a second one on the ADDM community website on discovery.bmc.com. And we are just now launching the BMC community pattern exchange space on the BMC community website. And it will have areas to share your patterns, or even just your TPL code snippets, things like user-defined functions that you use all the time and think that other people might find useful as well. And we'll also have an area to raise ideas for new patterns to be developed. So this space is about to be, or it has been launched. It's about to be populated already with some information. So please look out for that. Thank you. I will now open the call to any questions.
Thank you. If you would like to ask a question, please signal by pressing *1 on your telephone keypad. If you are using a speakerphone, please make sure your mute function is turned off to allow your signal to reach our equipment. A voice prompt on the phone line will indicate when your line is open. And once again, that is *1 if you'd like to ask a question. We'll pause for just a moment. And as a reminder, that is *1 if you would like to ask a question. And there are no questions via the audio. Sir, I'd like to turn it back over to you for any additional remarks.
Thanks, Amy. As Nick mentioned at the end of the webinar, there certainly is the community site. If you have any additional questions or you think of some after the webinar and would like to ask those, please link to the site. Also, following the webinar, you will receive a quick survey. We'd like to know what you thought about the contents of the webinar. And any questions you may have, you can certainly post them there. You'll also be directed to the community's webinar site once the WebEx terminates. Well, thanks, Nick. Thank everyone for attending. Have a great day.
Thank you, everyone, for attending.
And thank you. That does conclude today's presentation. Thank you for your participation.